So we've been working with right triangles. So that's the first thing I want to do is mark these as right triangles. So we have some right triangles. I don't know what happened to that pen. That pen's not working. So we're going to mark these guys as right triangles. And today we're going to start looking at special right triangles. And I see far too many of you staring at a screen. So stop staring at a screen and start staring at my board. So the first type of special right triangles are 45, 45, 90. So I'm going to mark all of these as 45, 45, 90s. And we want to see if we can kind of come up with a pattern on how this is going to work. That's the worksheet from Wednesday. I think you needed it. Oh, yeah. So on this first triangle, right now we're just kind of paying attention. I'm going to put ones here and here. And I'm going to use Pythagorean theorem to figure out what the longest side is, the hypotenuse is. But I'm not going to get a decimal like what we did earlier in the week. I just want to leave it as a radical. So what's Pythagorean theorem again? Right. So A and B are going to be these two. So 1 squared plus 1 squared equals C squared. Well, 1 squared just 1. 1 times 1 is 1. 1 times 1 is 1 equals C squared. 1 plus 1 is 2 equals C squared. And before, at this point, we'd grab a calculator and hit the square root of 2, which would give us like 1 point something. But I don't want to do that. I just want to leave it as the square root of 2. So if my legs are 1, my hypotenuse is the square root of 2. Now, we're going to see if we can kind of come up with a pattern. So then we're going to do 2 more to see if there's a pattern. So let's pick 5. So let's put 5 here. Well, same as before, 5 squared plus 5 squared equals I don't know squared. We're using Pythagorean theorem. 5 times 5 is 25 plus 25 equals C squared. Add these together, I get 50 equals C squared. I don't want the square root yet. Well, I will be squaring. So then I square root the 50, and I want to actually reduce that radical. I don't want to get a 7 point something. So 50 I know is actually 25 times 2. And I know 25 is 5 times 5. So this would actually turn into 5 radical 2. So, if my legs were 1, I got a hypotenuse of, I didn't put the 1, but I could have, 1 radical 2. If my legs were 5s, I got 5 radical 2. And we're going to do this one more time just to see if it kind of still holds true. So somebody give me a number to try. Don't get too crazy. 7. So let's do 7. 7 squared equals C squared. 49 equals C squared. Add those, we get 98 equals C squared. When I take the square root, 90 is actually 49 times 2. The square root of 49 is 7. 2 gets left behind. So I still get 7 radical 2. So that's why this 45, 45, 90 is considered a special right triangle, because there's some definite patterns that showed up. Next week, I hope, if we end up being here enough days to do it, we have a 30, 60, 90 degree triangle that also has some patterns. So this is the one we're working on today. So we're going to pass out a worksheet. We're going to do the worksheet mostly together. At the end, I want to see how ready we are for Pythagorean theorem. Because if we are here at all next week, even if it's just one day, we will be having a quiz on Pythagorean theorem. If we're here 3 days, we'll also have a quiz on special right triangles. But no matter what, if we are here, there will be a quiz on Pythagorean theorem.
If the weather to be believed.
Yeah, sometimes the weather people can make mistakes. So we shall see. But I should be able to get the Pythagorean theorem part in next week. At the tail end of the class is a quizzes that we're going to do just so I can see how ready we are for that quiz. It's only 5 questions. I'll have you do it just to kind of see where we stand. Everybody get a 45, 45, 90? So, let's take a look. Switch into that worksheet. So, as usual, my worksheets are kind of a mix between notes and worksheets. I'm going to be doing a lot of that here lately. So I've got a great big blank spot here, so I have someplace to write. So the first thing I want you to do is draw yourself a right triangle. Try to make sure the right triangle, the 2 legs look very equal. So don't do a real skinny one. Make sure these are as balanced as you can. Draw the hypotenuse. And we're going to mark this 45, 45, and then the box for 90. So that's our special right triangle, 45, 45, 90. So go ahead and get that drawn. Now, we know from what we just did, because these 2 angles are the same, these 2 legs will also be the same. So whatever they are, they will match. So we're going to put X's in those 2 positions. And then based on the pattern we kept seeing, whatever this is going to be that number times the square root of 2. That number times the square root of 2. So there's my pattern. So when we get around to doing this quiz, I will give you this picture. You will get this picture. For the Pythagorean theorem, you will get a squared plus b squared equals c squared. You'll get that. Now, if I have a leg and I need to get to the hypotenuse is bigger. So if it's leg to hypotenuse, you're going to multiply by square root of 2. So if I give you a leg and you're getting to the bigger side, you're going to multiply. Vice versa, if I'm going the other way, if I give you a hypotenuse, and we're going to a leg, then we're going to divide by radical 2. So there's my steps. That tells me what I need to do. So I'll give you a moment to get this written down, then we'll start looking at some problems. Does anybody need more time to write this down? You good, Jamel? Yeah. All right, so let's look at the first 2. Number 1 is as easy as they can get. And you'll see that here in just a second. So number 1, first I have to decide is what number did I give you? I gave you a 4. Is the 4 in a leg or a hypotenuse position? It's a leg. So if this leg is 4, this leg will also be 4. Because the legs always match. Always, always. And then I said, leg to hypotenuse, what do? Multiply by radical 2. So kind of down below here, I'm going to write this, 4 times square root of 2. But I can't even really do any work with that. All I can really do is just to write it. So I get 4 radical 2. So like I said, that's as easy as they can get. If I give you the leg, and the leg is a whole number, the legs are going to match. The hypotenuse will then be that whole number square root of 2. Well, now we're going to see one that gets a little bit trickier, but still not bad. So number 2. Again, I gave you a leg. So 5 radical 2 is a leg. So this leg is going to match. 5 radical 2. Well, again, leg to hypotenuse, I'm going to take my leg times the square root of 2. Now, this is why I spent some time Wednesday reviewing multiplying and dividing by radicals. Because we're going to have to multiply. Now, the 5 was already out here. And I've got 2's. And remember, 2 2's underneath means a 2 can come out. So then I'm going to multiply by 2. Because radical 2 times radical 2 is just a plain old 2. And 5 times 2 is 10. So this hypotenuse is now 10. So it's a little bit harder because I had to do a little bit of work with the radical, but not too bad. Just a little bit harder. Now, when it comes to a quiz, if you can at least give me this, I will give you something because you knew the pattern. But to get full credit, you'd have to get to the 10. But I will give you something if you knew you had to multiply by 2, or square root of 2. Does anybody need any more time for 1 and 2? Slide 9. Number 3, I give you a 10 radical 2. Where's the 10 radical 2?
Hypotenuse.
It's the hypotenuse this time. So if I give you the hypotenuse, I got to backtrack to a leg. And what did I say at the top that I have to do hypotenuse to leg?
Divide by the square root of 2.
Right. And we know from the worksheet from last week, division is actually a fraction. So if you're dividing, you're going to make a fraction and put the square root of 2 on the bottom of a fraction. Now, remember from last week I said if you can reduce the radicals, do that? Well, the radicals just go away. Because on both of these, I got a radical 2. So the radical 2's can just cancel. And I'm left with just a 10. So a 10 here and a 10 here. So it actually turned out like number 1 and number 3 were very similar. Number 1, I gave you a whole number for the leg. So the hypotenuse was that number radical 2. On this one, I gave you a whole number radical 2. So therefore, the leg is just the whole number. Now, number 4 gets a little bit trickier. Actually, this is one of the trickier ones. But the 8. The 8 is in what position? It's hypotenuse. So therefore, hypotenuse to leg, what do? Divide by radical 2. And if you can tell me that both legs look like this, I will give you something, because you need the pattern. But I can't leave it like this. And I meant to do some of these Wednesday, and it just didn't work out. So I'm not allowed to leave a radical in a denominator. I can't leave that radical down. I didn't have any that didn't kind of fix itself on that worksheet. All of them had like square root of 16, square root of 25, and it just kind of disappeared. But this one, the square root of 2, can't just disappear. So what I have to do is I'm going to have to multiply the top and the bottom by radical 2. So whatever this is, if I multiply the top and the bottom by that exact same radical, it's going to actually make the bottom radical disappear. And that's known as rationalizing the denominator. Like I said, that's what makes this one a little bit trickier than the rest. Well, on the top, 8 radical 2. On the bottom, square root of 2, square root of 2. I've got 2 2's so the 2 can come out. So I get just a plain old 2. Now, if you remember the last step from when I was dividing Wednesday, my last step was to, if you can reduce the whole numbers, reduce the whole numbers. So can the whole numbers reduce on this one? Yeah. The 8 and the 2 can both divide by 2. So 8 divided by 2 is 4. Two divided by 2 is 1. I mean, I can put the 1, but I don't even really need it. So therefore, this is both legs. 4 radical 2, 4 radical 2. Now, like I said, that's a bit trickier because you had to fix the bottom. That's one of the trickier ones that we're going to have. It's a little bit tricky. Are we okay on 3 and 4? Now, when we're going through these special right triangles, basically I've got one day of these. The next day is the 30, 60, 90s, which will be done mostly together again. And then the last day is kind of a mixed up worksheet that'll be done mostly by you guys. So that's kind of the pattern that we're doing. That's why I said if we are here 3 days next week, I should be able to get to a quiz. But I do have my doubts. Number 5 is a whole lot like number 4. A whole lot. The 9, what spot is it in? It's hypotenuse. So that means I got to go to a leg. How do I go to a leg?
Divide by radical 2.
Divide by radical 2. And like I said, if you write this for both the legs, I will give you something because you knew the pattern. But I need to fix it. So to fix it, what did we do again?
Multiply by radical 2.
Right, multiply radical 2 by radical 2. Does anybody remember doing that from previous years? Now, you probably would have done it maybe 8th grade. Like I said, last year they said they didn't get to it, but you might have had some simple ones in 8th grade, but that was a while ago. So now I have 9 radical 2 over 2 2's, so the 2 comes out, 2. Now in this case, I've got a 9 and a 2, so I can't reduce it. Do not. I had somebody trying to change this to a 4.5. Don't do that. It just makes a mess out of everything. Just leave it like this. So 9 radical 2 over 2. 9 radical 2 over 2. Those are my legs. Number 6, I want you to try. It is a whole lot like number 2. So if you need an example, look at number 2. So try number 6. Number 6 looks a whole lot like number 2. Give it a shot. Good job. And on all of these, you're always finding 2 sides. You're either finding both legs, which are the same, or you're finding the leg which matches and then the hypotenuse. But there's always 2 things you have to put in position. Same with the 30, 60, 90. I give you one of them, you have to find the other 2. But on those, they're all different. So it takes a little bit more work. So 6, 2 radical 2 is in which position? It's a leg. And I know it's a leg because here's my 90. That must be the hypotenuse. So these must be legs. And I know the legs match. So that I just have to write down. Leg to hypotenuse, what do I do?
Multiply by square root 2.
Multiply by square root of 2.
Radical.
Either one. Like I said, that word is interchangeable. So we're going to multiply by the square root of 2. Now, the 2 are okay. These 2's are both underneath the radical. So 2 on the inside, bring one of them out. 2 times 2 is 4. So I get just a 4 there. that was number 6. Not too bad. Are we okay on that one? Number 7. Very similar, but it takes a little bit more simplifying. So try number 7. 8 we're going to do together because I'm giving you a fraction in the first place. So it's a little bit different. But try number 7. Try number 7. Now remember your steps when you're multiplying radicals. Because remember the first step was to factor the numbers under the radical. The second one was to bring out anything that can bring out. And then this one won't be the cleanup step. So what, I got a square root of 6. The square root of 6 is in what spot?
Like,
It's a leg. So the other leg's going to match. Leg to hypotenuse, what do I do? Multiply by radical 2. So if you can give me this much, I will give you something. Now I've had a lot of people kind of throughout the day just go ahead and multiply this and say it was radical 12, which isn't wrong. It's just not simplified, and you need to simplify to get full credit. So that's where, like, remember last Wednesday, this past Wednesday, you had to break the 6 apart. So 6 is what times what? So 6 is 3 and 2 times the 2 that was already here. So now everything's broken apart. And if I have 2 of something, I can bring it out. So is there anything I can bring out?
Yeah.
So 2 can come out, and what has to stay under? 3. So that's the answer I'm looking for, is 2 radical 3. So that's my hypotenuse. Now, like I said, if you put radical 12, I mean, it's not wrong, it's just not really finished. It's not simplified. But at least you knew the pattern. So I will give you something because you knew you had to multiply. Now 8. What did I give you on 8?
fraction.
Gave you a fraction, and the fraction's in what position?
Leg.
It's a leg. So the other leg's gonna match. So let's make the other leg match. So that's pretty easy. So now I'm gonna go 5 radical 3 over 6. And if I'm going to hypotenuse, what do we do again?
Multiply by the square root of 2.
Say that one more time.
Multiply by the square root of 2.
Multiply by the square root of 2. And if you have a fraction, when you multiply, it's going to go on the top of the fraction. If you had to divide, you would put it on the bottom of the fraction. So if you start with a fraction, when you multiply, put it on top. When you divide, stick it on bottom. Well, this one, there's not a lot I can do with it. 3 and 2, I mean, they don't factor out. They can't like do anything, but I can multiply them together. So 5 radical 6 over 6, that's pretty much it. So 5 radical 6 over 6 is my hypotenuse. So I didn't really simplify much. But the only thing I could do is multiply those 2 and 3. You all right? We got 2 more to go on this. And then, like I said, there's a little like quizzies that'll give you the code. It's not in Google Classroom. That I just want to kind of see where we stand on Pythagorean theorem. 5 questions. So far, we've been hovering around a 70. I think the highest has been a 74 right now for the class. So this guy. 9. Number 9. What am I giving you? Leg or hypotenuse? Leg. So this leg's going to match. So just write it again. Pretty close to the last one we did. Because going to hypotenuse, again, we're going to have to multiply by the square root of 2. Now, the last one, I had a 3 and a 2 that I couldn't really do anything with, so I just multiplied them together. But this one, I have a 2 and a 2. So that means the 2 can come out. So 3 is already out. 2 can come out. And 2 is already below. And because I have 2's on top and bottom, I can just cancel out my 2's. And I get 3. So 3 is my answer there. Number 10. 4 radical 5. What spot's in it? It's a hypotenuse. So that means I want to go to a leg. And what did I say that we had to do to go to a leg again? Divide by radical 2, which means put it on the bottom of a fraction. Well, it's one of these messy ones again. Because I can't leave it like this. Now, if you give me this, I'll give you something. But I can't leave it like this for full credit. So what am I going to have to do to fix it?
Multiply by radical 2 over radical 2.
Bingo. So multiply by radical 2 over radical 2. So now I have 4 radical 10. The entire reason we did this was to get this 2 out of the radical. So now I have just a plain old 2. Now remember, the last step on any of these is to reduce if I can. Can I do one final reduction on this thing?
Yes.
I can divide by 2. Again, don't touch the 10. The 10 it's there. Don't touch it. When you do the last reduction, you're only reducing the whole numbers. So I get 2 radical 10 over 1, but I don't even really need the 1. So 2 radical 10. Now, like I said, this one was mostly together. The next one, the 30, 60, 90, is mostly together. Then there's going to be one I'm going to give you that has some of each that I want you to do mostly by yourself. And I'll walk around and help you if you need help. Any questions on this one? So I think everybody was keeping up. I just want to kind of double check. So just kind of keep these handy so I can look at it, so I can mark it. You're going to need your computer. You're going to want a piece of scrap paper. And then probably something with a calculator. Like I said, the Quizzes only has 5 little questions. I'm going to go ahead and shut this off.